Thank you, Dr. Reinhardt. Can you all hear me? I do speak in a very different accent, so, okay. Can you all hear me now? Okay. If any of what I speak does not sound familiar, please wave your hand and stop me and ask any question. I do speak in a very different accent, so. And I'm trying to figure out how this works. Can we get one of these lights off, please, in the front? So. I'm going to begin by speaking about the geographic distribution of anaplasmosis. To begin with, this disease has been known, anaplasmosis in cattle, for at least half a century now. It's been known as under different names. Some of the symptoms have been lumped up with diseases that are similar to anaplasmosis, but it is quite a common disease in the tropics and subtropical region throughout the world. Specifically in the US, there are areas in the US that are considered enzootic or endemic, or areas that are considered established, and they lie in the south, close to the Atlantic Gulf Coast, the Atlantic states, many of the Midwestern states, and also some of the Western states that are considered enzootic to this disease. Now, even in the places where this disease is not considered established, the states in those regions have consistently sent anaplasmosis or reported anaplasmosis in their cattle herds. And primarily the reason for that is, as it has been pointed out earlier, is the transport of carrier cattle from enzootic places to places where the disease has not been established yet, and the subsequent mechanical or biological transmission of the disease from infected animals to non-infected animals. The distribution of this disease, as we know of in the US, is expected to change, largely because of changing weather patterns and the recent changes and the anthropogenic influences on disease systems overall. This is true not only for the US, but also for the whole North America. An example of this is the identification of different strains of anaplasma in a bison herd in Saskatchewan, Canada in the year 2000. The disease has been contained in Canada. It's not a problem there anymore, but definitely there's going to be some shifts in as far as the area of anaplasmosis, or the distribution of anaplasmosis is concerned. This has been mentioned earlier in the previous talk. I'm just going to summarize this very quickly. The transmission of Anaplasma marginale from an infected animal to a non-infected animal can happen in any one of three different ways. Mechanical transmission occurs when either biting flies, when they're looking for a blood meal, feed upon an infected host. They take the bacteria with them or the rickettsia with them, and then they mechanically pass it on to a non-infected animal. So since they take multiple blood meals, it goes from one animal to another animal and end up transmitting the disease that way. And obviously, as it has been pointed out, this is also quite possible by accidentally using blood-contaminated fomites, surgical instruments, and things of that nature. So mechanical transmission is one important, very important mode by which this disease is continued. Transplacental transmission also occurs in endemic areas where contaminated blood is passed through the crosses over to the placenta in the uterus of the mom to the calf. It is a significant part of the anaplasmosis epidemiology in endemic regions. And the third and by far the most important way by which anaplasmosis keeps going is the biological transmission that involves ticks. Ticks attaches themselves to an infected host. They have a blood meal. They end up ingesting the contaminated blood, which multiplies in their gut and salivary glands. And when the ticks find another host, they then pass those bacteria to the second host and the third host and so on. So even though a couple of things are important to note here is, one, the mechanical transmission and the transplacental transmission, there is no replication of the bacteria. It's only with the ticks that You can start with very few bacteria, but then by the time the ticks bite other animals, you have multiple bacteria. So it really biomagnifies the whole situation. I'd like to talk more about the ticks, but before that, I'd like to spend a few minutes talking about some of the flies that have been implicated as mechanical vectors for this disease. And first of those is the stable fly. Stable flies are fairly common in Kansas. They are more prevalent in Missouri and going south in the southern states and southeastern part of the country. Stable flies look very similar to houseflies. They're just a tiny bit smaller than a housefly. They're about 5 to 7 millimeters long. It is possible to tell them apart, a housefly from a stable fly, by looking at their mouth parts and their some morphological characters in their abdomen and so on. But stable flies are obligate blood feeders, which means they have to have a blood meal before they're able to complete their life cycle as an adult, and also they have to have a blood meal in order to reproduce. So for this, they go after cattle, they go after deer, and if they can't find those two, they come after us. So they have to have a blood meal in order to do this thing. A little bit about the life history or the life cycle of a stable fly. An adult female, when it's had a chance to have a blood meal, can lay somewhere up to 600 to 800 eggs. And those eggs are laid in batches of 50 to anywhere from 50 to 100 eggs at a time. And before she lays each batch of egg, she has to go and get a blood meal, which means in her lifetime, which lasts about 9 to 12 days, she can have a blood meal a day. The eggs are usually laid in decaying debris in a moist organic area. The eggs will hatch in about a couple of days. They will go through several larval stages. There are at least 3 to 4 different larval stages. The larva will then become a pupa, and the pupa will then emerge as an adult. The whole lifetime, going from an egg to an adult, would probably take about 3 weeks. So we might expect in Kansas conditions, we might expect at least 4 to 5 generations of stable flies through middle of spring all the way through early fall. When you start seeing stable flies in your pasture, on your cattle, that is usually an indication that the problem is already there. And whether or not you're interested in controlling anaplasmosis or any other blood-borne parasite that these flies are transmitting, it is advised that you keep count of the number of flies that are out there. So you start doing some management. And I think the recommendation is that you count the number of flies on the front 2 legs of cattle. And if the number is over anywhere between 3 to 10, depending upon the state you're in, you then start doing some management to control the stable fly. Otherwise, you start seeing economic damage being done. Stable flies are notoriously hard to control because they breed. The only life stage we see of stable flies are the adults. Everything else is somewhere else in the environment. So any control that we plan should consider the fact that the eggs, the larva, and the pupa are someplace else. The stable flies, you only see them for 5 minutes on the cattle, and after they finish feeding, they're off to hiding under foliage, or they're sitting on the fence and things like that. So control has to consider the entire life cycle of a stable fly. And they can also disperse very quickly. Within about 24 hours, they are known to travel as far as 30 kilometers in a day. The other common fly species in Kansas that are also implicated as a mechanical vector for anaplasmosis are the tabanids. There are over 200 different species of tabanids in North America and throughout the world, but it's only the horseflies and deer flies that are often associated with cattle and bovine anaplasmosis. Horseflies are very easy to find. They're pretty big. They're 1 to 2 centimeters big. They have really big eyes, and they have this nasty mouth parts. They are very aggressive biters. They have to again have a blood meal in order to go through complete the life cycle and be able to reproduce. They start emerging around this time of the year, and they keep going until early fall. Excuse me. Horseflies are usually, as soon as they emerge, the males and female flies look very similar. They start feeding upon plant sap, which is really high in sugar, which will keep them going for some time, but they have to find a blood meal in order to reproduce and produce viable eggs. Some females can lay eggs without mating, but most have to have a blood meal. And when the female has had a chance to have a blood meal, she would lay up to 800 to 1,000 eggs. All the eggs are laid in one big batch, and they usually around a body of open water where there is a reservoir or a stream, because the larval stages, once the eggs hatch, has to be in water for them to go through the larval stages. So they develop underwater or in a semi-aquatic type environment. And then they come out as pupa, and then they emerge as adults after about 3 to 4 weeks period of time. So for Kansas conditions, we would probably expect about 3 to 4 generations of horseflies and also deer flies, which has a very similar life cycle in Kansas. So even though table flies and horseflies are only mechanical vectors, they can be very efficient transmitters of the disease. One study that was done in Georgia a few years ago demonstrated that it only takes less than 10 bites for a deer fly to contract disease or transmit disease from an infected host to a non-infected animal. And also I should mention it's the pupal stage of these flies that overwinter. So if the conditions become really cold, they become a pupa, and then they're either under leaf litter or in organic matter. They stay that way until the conditions become warm again, and then they'll start emerging as adults the following season. Again, horseflies are somewhat notorious to, it's very hard to control them, just like stable flies are. There are also other flies that are associated with cattle in our part of the country, particularly house flies and phase flies. But these flies do not have the appropriate mouth parts to draw blood from an animal. They're not interested in a blood meal. So they have no consequence for bovine anaplasmosis, so far at least. And then there is the hornfly. Hornflies are also, they do bite. They do have the mouth parts that can draw blood, but they're mostly interested in just one animal at a time. So if they feed on an animal, they're not going to go from one animal to another animal and then potentially passing on a disease that way. So they have relatively less consequence in terms of transmitting bovine anaplasmosis. So Dr. Rethorst and Dr. Olson talked about this a little bit, and this is a topic on its own. I can spend a whole day talking about how to control and how to minimize damages because of these flies. I'm not going to be able to go over all of that today, but here are some basic things that we can do that will help minimize the damage. Keep the animals clean, clear out manure and spilled feed as frequently as possible. There are some recommendations that you do that at least once or twice a week. Remove standing water and improve drainage, because if you have to keep in mind that the flies are, most of the life of the flies are spent in places where there is decaying organic matter. So as long as we keep that under control, we can do a better job at controlling this disease, or at least these flies transmitting the disease. And larvicidal applications at appropriate times and locations are important, but also we have to keep in mind that they have a tendency to run off to the streams, so we have to be very judicious about what kind of applications we are going to be using. Then there are the, people have wondered about the role played by wild ruminants in this whole mix of, in the epidemiology of bovine anaplasmosis. They've particularly looked very hard at white-tailed deer, and they've wondered about, has it got any role to play in bovine anaplasmosis at all? And so far they have not found that white-tailed deer has got anything to do with anaplasmosis. They're not carriers. Naturally, they do not get infected, and they've tried very hard and they have not come up with any evidence at all that suggests white-tailed deer has got anything to do with it in North America. But Mule deer and elk have been suggested as potential reservoir hosts, but it's not in Kansas, it's in other places in the country. I just threw it up there so we get a complete picture of the epidemiology of this disease. So that brings me back to the ticks. Ticks, again, are biological vectors for this disease. There are over at least 20 different species around the world that have been implicated as vectors for this disease. And of those 20 species, we are lucky to have only 4 of them in North America. And of those 4 species, which all belongs to the one group called Dermacentor, we only have 2 species in Kansas. And one of them is Dermacentor variabilis, or the dog tick, and the other one is Dermacentor andersoni, which is the Rocky Mountain wood tick. Rocky Mountain wood tick is not very prevalent. It's only found in the western and northwestern part of Kansas. So you go to western parts of Nebraska, Wyoming, that's where these ticks are more prevalent. So this ultimately brings our situation to just one tick in Kansas, which is Dermacentor variabilis. Again, it's called the dog tick. Now, when you and I go out this time of the year, we get covered in ticks. We come home and we start picking ticks off of us or our dogs. Those ticks are mostly going to be Lone Star ticks. They're not the tick that I'm talking about. Lone Star ticks have this conspicuous white marking on the back. It's very easy to spot, and that's the tick that most likely you and I would encounter in Kansas. And they have nothing to do with anaplasmosis. Again, it is only the wood, it's the American dog tick that transmits bovine anaplasmosis or acts as a biological vector for anaplasmosis in Kansas. And we've collected ticks in Kansas for the last 2 or 3 years. Our experience is that in southeast Kansas, for every 10 Lone Star tick that we catch, we get about 1 or 2 dog tick. And as you keep going west, around here, the ratio becomes more or less balanced. For every 5 amblyomma tick you collect another 5 Dermacentor ticks. And as you keep going west, the ratio kind of flips. You get more dog tick, and you get less and less Lone Star tick as you keep going west. And this is what a Dermacentor variabilis tick would look like. If I can find this right. The image on your left is a female adult tick. The one on the center is a male tick. They look almost similar. They have this characteristic teardrop type shape. You can easily tell them apart from other ticks by looking at the white or silver grayish marking on the back of the tick, which tells them apart, especially from a Lone Star tick. These images obviously are blown up to several magnitude, but these ticks are usually just 5 millimeters long. The females are slightly larger than the male. The male's probably 3 to 4 millimeters long, and they look kind of very similar to each other. And this is what a tick looks like on the far right side on this slide. Is a fully engorged female that had a chance to blood feed on a cattle. So that can get as big as 15 millimeters wide and then 10 millimeters long. And that one right there is full of blood and most likely with several thousands of eggs, and she's ready to fall off and start laying eggs. And this is the life cycle of a tick. Dermacentor, or American dog tick, happens to be a 3-host tick, which means really the ticks go through, they hatch from the eggs and become a larva. The larva then becomes a nymph, and the nymph then becomes an adult. And each one of those life stages have to feed on an individual host. So they jump on a host, they feed, they drop off, they find another host, they feed, and then they drop off, and then keep going that way. So you have a tick, a female tick, laying several thousands of eggs at a time on the leaf litter in organic area. They hatch to become larvae, which attaches themselves to rodents like mice and other small rodents. They're on there for 3 to 4 days. They have a blood meal, then they drop off. Then they go on another small mammal as nymph. They feed and they drop off. And they have a choice. They make a choice based on weather conditions. They either decide to go become an adult if the conditions are suitable, or they stay as a nymph and then overwinter, and then they become an adult in the next season. So when the nymphs and adults are in the environment, they typically climb up a blade of grass or low-lying shrub, and then they sit waiting for any passing by small mammal. And as we brush against the vegetation, they usually find us by either their sense of smell or by their sense of identifying heat signals from passing by mammals. They attach to us, they have their blood meal, then they drop off. Usually dermacenter variabilistics are looking for dogs and cattle, of course, and deer and animals that are much bigger. So if I want to go back and summarize everything I said of the whole transmission cycle, on the left is the mechanical transmission where the pathogen is taken from one infected animal to another infected animal purely by mechanical means. The flies that are biting, they are carrying the pathogen in their mouth parts, and then they're giving it to the next animal just in a purely mechanical way. On the right side of the schematic is the process where the ticks are involved. The ticks are biting, they get the pathogen, it multiplies in their gut and salivary glands, and the ticks can go from one host to another host. It's actually the male ticks that are notoriously looking for mating with multiple females on the same animal, or they can drop off an animal and then go look for another male, they mate, and then they go on another animal and keep that going. So for that purpose, the male dermacenter variabilistic, or the male dog tick, is typically considered as the reservoir host for Anaplasma marginale. So with all that background information out of the way, we've known anaplasmosis for a few years at the Kansas State Veterinary Diagnostic Lab. We know this is a problem, this is an ongoing problem that is going to get bigger. So we wanted to go out and do some studies that would help us understand the situation a little bit better. There were a couple of things we wanted to do. One, we wanted to know the prevalence level of Anaplasma marginale among some of the ticks in our area. So we went collecting ticks south of I-70 and east of I-35 the last 3 or 4 years. So we go out, we dress like aliens because we don't want to keep the ticks crawling up on us and giving us infection. It works 20% of the time. So we go out, we collect these ticks, we use this one square meter flannel cloth, and we sweep on the ground, and then we stop every 30 feet or so, we flip the cloth back, and we notice a lot of ticks. And they look something like that in the picture in the middle. And then we also put some CO2 traps. The ticks get attracted to CO2. So we brought those ticks back to our lab, we did some PCR analysis, and this is what we found. About a third of the ticks that we collected were positive for Anaplasma marginale. Again, this is southeast Kansas, south of I-70 and east of I-35. We did the same thing in 2015. We collected about 356 dog ticks. The numbers were pretty close. So every third tick that is biting could potentially transmit Anaplasma marginale to cattle. This is our data from Kansas. And we also found some other pathogens that are interesting, Francisella tularensis and Rickettsia, transmitted also by the dog ticks. The other question we wanted to ask basically were, has the disease increased over time in Kansas? And has it spread to new places? And are there any disease clusters in Kansas? So if we know there are clusters, then we can go after those clusters and try to understand this disease a little bit better and do some management possibly. We try to answer these questions using the data that we get at Kansas State Veterinary Diagnostic Lab. The tests that you guys are sending us have some county level information. So we took that county level information, and there were about a little over 4,000 cases that were submitted to KSVDL since 2009 through 2015. We took that data, and then we found, yes, we are seeing more and more cases that are being submitted to KSVDL, and those cases are coming from newer and newer areas. So if you had anaplasmosis this year, chances are that anaplasmosis is going to come from a neighboring county to yours. So the disease is spreading, and the intensity of this disease is increasing, has increased, and it's probably continuing to increase also. So here's what it looks like. The colors, the darker colors indicate counties that have a bigger problem than the counties that have lighter shade of the color of yellow. Going from 2009 on the top right, left-hand side to 2013 on the bottom right, you can see how this disease has spread over time. And in this image, you can also see some of the clusters of the disease where this is a persistent problem. And clusters usually indicate that the forces that are driving the disease are common for each cluster. So you can attack either its management practices, or is it the vector? We don't know yet what the conditions there are, but it is these clusters are pretty persistent, has been persistent for a very long period of time. So I just wanted to wrap up by concluding that horseflies, table flies, and ticks all contribute to bovine anaplasmosis in our state. I hate to see Kansas as one big state. Of course, we have so much difference in geography going from east to west. The problem obviously is much bigger in south and the eastern part of the state, and not so much in the western part of the state. But the horseflies, ticks, and stable flies are contributing to this problem throughout the state. We have the ticks that has the pathogen. It's not like we are always getting infected cattle from elsewhere and they are giving us the disease. We have the ticks and we have the flies that can keep the disease going for some time. More anaplasmosis cases have been seen, just like I mentioned, at KSVDL over the time, going from 2009 through 2015. And I think that trend is continuing to go up. And it is going to keep going that way because of the recent changes in weather patterns and anthropogenic changes and so on. And fly and tick control strategies will definitely minimize some of the losses because of this disease. And I apologize, I couldn't go on and discuss that topic in detail. That's a topic on its own. But I hope there is enough information here that you all can take home today.